In 1942, Britain required disposable suppressed weapons. The requirement originated within Special Operations Executive Offices. Clandestine units demanded minimal acoustic signature. Existing pistols lacked sufficient terminal performance. Standard STEN guns produced excessive mechanical noise. Engineers evaluated suppression of the STEN platform. Design responsibility fell to RSAF Enfield engineers. The project received the designation STEN Mark II S. The suffix indicated an integral suppressor assembly. The baseline weapon remained the STEN Mark II. Receiver tubes retained standard mild steel construction. Outer diameter measured approximately 38 millimeters. Tube wall thickness remained roughly 2 millimeters. Manufacturing relied on simple drawn steel tubing. Cost reduction remained a primary procurement objective. Then the suppressor body extended significantly beyond the barrel. Overall weapon length increased to approximately 900 millimeters. Weight rose above 3 kilograms unloaded. Balance shifted noticeably toward the muzzle. The suppressor consisted of two primary chambers. The forward chamber housed multiple steel baffles. The rear chamber functioned as an expansion volume. Internal volume exceeded most contemporary suppressor designs. Engineers prioritized gas containment over compact dimensions. The barrel featured a series of radial ports. Porting began forward of the chamber throat. Approximately 40 small ports were drilled circumferentially. These ports vented propellant gases into the suppressor. Gas venting reduced projectile velocity below supersonic threshold. Subsonic performance minimized ballistic crack signatures. A standard 9mm cartridge remained specified. No special ammunition was strictly required. However, velocity reduction varied between ammunition lots. This inconsistency complicated acoustic performance predictions. The bolt remained largely unchanged from Mark II pattern. It operated on simple open bolt blowback principles. Bolt mass measured approximately 600 grams. The recoil spring remained standard wire construction. Spring rate required no major modification. However, suppressor back pressure altered cyclic behavior. Observed cyclic rate averaged around 500 rounds. Some test units displayed reduced cycling consistency. Excess fouling accumulated rapidly within the suppressor. Carbon deposits formed thick internal layers. Condensed moisture combined with powder residue. Maintenance intervals proved shorter than anticipated. Field cleaning procedures required partial suppressor disassembly. Disassembly demanded specialized spanner tools. SOE operatives rarely carried proper maintenance equipment. Improper cleaning caused significant reliability degradation. Magazine compatibility remained unchanged from standard STEN pattern. 32-round double-stack magazines were issued. Magazine feed geometry already possessed marginal reliability. Suppressed firing increased sensitivity to feed friction. Cold weather further worsened feeding performance. Lubricant viscosity affected bolt return speed. Trials recorded multiple failure to feed incidents. Ejection reliability remained generally acceptable. However, weak ammunition caused occasional short cycling. The weapon fired from an open bolt position. But this design increased first shot mechanical noise. Suppressor efficiency could not eliminate bolt clatter. Close observers still detected metallic cycling sounds. SOE documentation acknowledged this limitation explicitly. The trigger mechanism remained crude but serviceable. Pull weight averaged approximately 4 kilograms. No provision existed for selective fire modes. The weapon remained fully automatic only. Short controlled bursts required operator discipline. Barrel heating became significant during extended firing. Suppressor temperature rose rapidly after several magazines. Heat transfer to the outer tube was substantial. Operators risked burns during prolonged engagements. No dedicated thermal shielding was installed. Production emphasized speed over ergonomic refinement. Finish quality varied between manufacturing batches. Most components received simple phosphate treatment. Corrosion resistance remained acceptable for limited missions. The weapon stock used a fixed tubular design. Some units retained the skeletal wire stock. Length of pull remained relatively short. Stability during automatic fire was marginal. The suppressor mass slightly reduced muzzle climb. However, overall handling remained characteristically crude. Sight arrangement followed standard STEN configuration. A fixed front post was brazed in place. The rear sight offered two aperture positions. Sight radius increased slightly due to suppressor length. Accuracy improved modestly at short ranges. Typical effective range remained under 100 meters. Beyond this distance, dispersion increased noticeably. Manufacturing contracts involved multiple subcontractors. The component tolerances varied between production lots. Quality control inspections identified suppressor alignment issues. Misalignment occasionally produced internal baffle strikes. Such strikes severely degraded suppressor performance. Some affected weapons were withdrawn from service. Production numbers remained relatively limited overall. Distribution focused on SOE and commando units. Training materials emphasized careful handling procedures. Operatives received minimal formal armorer instruction. Field reports frequently mentioned maintenance difficulties. Suppressor packing materials required periodic replacement. Replacement kits were not always available forward. Logistical chains prioritized conventional infantry weapons. Spare parts supply remained inconsistent throughout 1943. Some units improvised cleaning using improvised tools. These practices sometimes damaged internal baffles. Engineering staff noted accelerated wear patterns. The weapon still fulfilled specific niche requirements. Close-range sentry removal remained its primary role. Procurement officials considered it a specialized tool. Wider infantry adoption was never seriously proposed. Post-war evaluations reviewed the design critically. Reports highlighted maintenance burdens and fouling rates. Later suppressor designs adopted improved baffle materials. The Mark II's nevertheless demonstrated functional viability. It represented a compromise between cost and stealth. Its disposable philosophy shaped several later concepts. The weapon remained in limited inventories after 1945. Gradual replacement occurred with more refined suppressed systems. Archival documents continue to record mixed operational feedback.